morning to all. Today we have to discuss about thermodynamics chapter. Thermo means heat, dynamics means movement. Okay. Thermodynamics mainly explain about the how does transfer of heat energy. So that means it explains various of heat energy. It explains various of heat energy. Next, thermodynamics explains whether chemical reaction takes place or not under the proper set of conditions. Okay, by using thermodynamics, we have to predict whether chemical reaction takes place or not under the set of conditions. Okay, next another important point. Thermodynamics only explain about macro models but not explains micro models. So thermodynamics only explain about macro models but not micro models. Okay. Then here another very important point. Thermodynamics only explains, that means only predict whether the reaction takes place or not under the set of proper conditions, but cannot explain rate of the reaction. Rate of the reaction means speed of the reaction. Cannot explain rate of the reaction and mechanism of the reaction. Understand now? Thermodynamics only explain whether reaction takes place or not. How much energy transfer, that's all. But it cannot explain speed of the reaction and mechanism of the reaction. That's why it cannot explain rate of the reaction. Rate means speed. Rate of the reaction or mechanism of the reaction. Mechanism of the reaction. This is the introduction part of the about thermodynamics. Then next some terms we should learn. What are the terms? Just see. System, we have to learn system, surrounding, universe, and border, Okay, what is the system? What is the surrounding? What is the universe? What is the border? Okay, listen. This is one container having some liquid. Okay, so inside the container liquid is there. So this inside the container is the system. Inside the container is the system. Container surrounding, outside of the container some space is there. So outside of the container is called surrounding. This is outside of the container space. This is surrounding. Okay, whether real line or imaginary line between system to surrounding, whether real line or imaginary line between the system to surrounding is called, this is the border. System means it is the specific portion of the universe. Specific part of the universe. Inside the container only system. Inside the container only system. Surrounding means so outside of the container, that means surrounding means exclude system in universe. Surrounding equal to exclude system in universe. That means surrounding equal to universe minus system. Okay now. Next, border means it is imaginary or real line between system to surrounding. So this borderline may be rigid or non-rigid, may be conducting or non-conducting. Non-conducting means insulator. This borderline sometimes act as a conductor, sometimes act as a insulator. Understand now? Sometimes act as a rigid structure, sometimes act as a non-rigid structure. That's why this border may be rigid or non-rigid, may be conductor or insulator, may be real or imaginary. So this is about terms, this one. Next, types of system, important. Types of system. Types of system. We have three types of system. Open system, closed system, and isolated system. Open system, closed system, and isolated system. Okay. What is the open system? Open system means just open container. This container having tea or coffee. This is coffee. Coffee. Open container. This is open container. Open container or open vessel. Right. When we heat rise to the open container, okay, when we heat rise to the open container, the energy transfer from container to outside, okay, or energy transfer from outside to container, okay, heat energy means heat energy. Then mass means here which substance? Coffee. So open container means more and more heat rise means coffee is spilled outside of the container. Okay, coffee spilled to the surroundings of the container. That means mass also transfer from inside to outside. Heat energy also transfer from inside to outside. Understand? That's why here energy and matter both exchange, both transfer, both exchange. Energy and matter both exchange. Next, closed system. In closed system, we take closed vessel. Same coffee. Here, matter is coffee. Okay, this is closed vessel or closed container. Right. When we temperature rise to the closed vessel, matter cannot split to outside because a closed vessel. That's why matter not possible to split outside, but heat energy transfer from inside to outside. That means heat energy transfer from system to surrounding. Matter cannot possible. only heat energy transfer. Just you touch the container, automatically heat, you can observe heat. Okay, that's why closed vessel, heat energy only transfer. Heat energy only exchange, but not matter, heat energy only exchange, but not matter. Next, isolated system. Right, this is thermoplasm. This is coffee. This is thermoplasm. Right. So already knows regular life. In thermoplasm, 3-4 hours. More duration also. Heat of the liquid does not decrease. That means heat does not exchange from system to surrounding. So automatically this is closed vessel now. That's why closed vessel means matter cannot exchange from system to surrounding. That's why here heat and energy both cannot exchange. Okay, this is about the types of systems. Right. Next one. State of the system. Right. State of the system we can define. It can measurable properties like temperature, pressure, volume, heat capacity, like that. So state of the system we can define. It can measure properties like temperature, pressure, volume. So this state of the system we have studied two terms, state function and path function. This is important, state function and path function. What is the state function? It can measure only initial state of the system and the final state of the system, but not explain in between. In between means initial state to final state. How does process going on? It cannot explain. Only, for example, reaction A gives B. It explains only initial state means starting reaction at time equal to 0. Again it explains when the product is formation. So time equal to T means product formation. That means initial state, how does reaction start? Final state, when the product formation. That's all. That only explain. In between, how many steps is there? Okay, how many steps is there? How many substrates involving? So what is the role of catalyst? So how much concentration decreases? it cannot explain. Only initial step, final step. Okay, in between steps it cannot explain. Okay, state function means it explains only initial state and final state only. Initial state and final state only. It cannot explain in between what process going on. So examples, enthalpy, internal energy, entropy, Gibbs energy, like that. Enthalpy, internal energy, entropy, Gibbs energy, like that. Examples for state function. And heat capacity. Okay, these are examples for state function. Next, path function. What is the path function? It can explain initial state, final state, and also in between what process going on. That means what is the direction also it explains. Path means direction. Direction. So it can explain in between initial state and final state what direction reaction going on. How much concentration decreases. Everything it cannot explain. That's why path function explain initial state and final state and also direction of the process in between initial and final, and also explain okay, path direction or path of the process in between initial and final states. Okay. Examples: work and heat energy. Examples: work and heat energy. This is about the path function. Next one. Next terminology: intensive properties. And extensive properties. Intensive means the properties which are independent of matter. Extensive means dependent of matter. So intensive property means independent of matter. Extensive property means dependent of matter. Okay, examples are very important. Examples are very important. Intensive and extensive examples. In NEET exam directly they are asking intensive and extensive examples, right? Volume, internal energy, volume, internal energy, enthalpy, gives energy, entropy, heat capacity, force, surface area, okay. Extensive properties: molar volume, density, next specific heat, next pressure, temperature, surface tension, viscosity, pH values. Okay, here intensive properties, extensive properties. Volume belongs to intensive property. Molar volume belongs to extensive property. So internal energy, enthalpy, Gibbs energy, entropy, heat capacity. Heat capacity belongs to intensive property. Next, specific heat belongs to extensive property. Force, surface area. Here molar volume, density, specific heat, pressure, temperature, surface tension, viscosity, and pH values. So these are the examples for intensive properties and extensive properties. So examples are very important. In NEET exam they can ask directly question. Next one. Types of process. Okay. We have four types in there. Four types: isothermal, isobaric, isoporic, adiabatic. So we have four types of processes there: isothermal, isobaric, isoporic, adiabatic process. Another one also there, cyclic process. Okay, that also I will explain. So first isothermal. Right. Isothermal means temperature remains constant. Here temperature remains constant. constant. Then del T equal to 0. Del T equal to 0. Okay, temperature remains constant. Change in temperature equal to 0. Del T equal to 0. That means T2 minus T1 equal to 0. Okay. In this isothermal process, internal energy change del E equal to 0, enthalpy change del H equal to 0. Internal change del E equal to 0, enthalpy change del H equal to 0. Next, isobaric process. Isobaric process. Here, pressure remains constant. Pressure remains constant. So here, del T equal to 0. Change in pressure equal to 0. Isobaric process is the open system. This is very important. This is the open system. Open system. Okay, next one. Isochoric process. Isochoric process. Isochoric process. Volume remains constant. Volume remains constant. Volume remains constant. Okay, here change of value del V equal to 0. Change of value equal to 0. Right. Isochoric process is the closed system. Isochoric process is the closed system. Closed system. Next, adiabatic process. Adiabatic process. Adiabatic process. Adiabatic process means heat energy. Okay, heat energy transfer from system to surrounding to system is 0. That means no heat energy transfer from system to surrounding, or no heat energy transfer from surrounding to system. That means heat exchange 0 from system to surrounding. No heat exchange between system and surrounding. So that's why here Q equal to 0. Q equal to 0 in adiabatic process. Adiabatic process is called isolated system. Isolated system. Should remember, open system means isobaric process. Closed system means isochoric process. Isolated system means adiabatic process. Okay now. So in exam, theoretical questions indirect may come in. Then last process, cyclic process. Cyclic process. Cyclic process. What is the cyclic process? Cyclic process means the process going on from initial state to final state to again between how many process going on, not irrespective of how much process going on, final state again return to the initial state. Cyclic process means whatever process going on, finally again final state return to the initial state. Final state return to the initial state. That is called a cyclic process. In between different process going on. We don't need that one. Irrespective of what process going on, finally final state return to the initial state. Final state return to the initial state. Okay? So irrespective of what process going on, final state return to the initial state. Initial state. This is the cyclic process. Okay? Important one. In this cyclic process, change of enthalpy zero, change of internal energy zero, excited zero, entropy zero. That means, remember, all state functions becomes a zero. All state functions becomes a zero in cyclic process. Understand now? All state functions becomes a zero in cyclic